The F-15 Eagle and its variants have earned the nickname Kings of the Skies with their record of nearly 100 kills throughout the Eagle's long life. First designed in the 1960s, the airplane remains the preeminent air superiority fighter since 1976 when it first came into service. Originally designed to counter the latest generation of Soviet MiG and Sukhoi superfighters, the F-15 could outturn anything in the sky to bring its missiles to bear first. It is still a potent fighter and strike aircraft, able to carry America's most lethal conventional armament. It played a significant role in ousting Saddam Hussein's forces from Kuwait during Operation Desert Storm. The McDonnell Douglas F-15 Eagle is one of the world's most formidable interceptor fighters. Although largely designed in the late 1960s and early 1970s, it still remains the primary air superiority fighter serving with the U.S. Air Force and will remain so for the rest of this century. In service with the United States, Israeli, and Saudi Arabian Air Forces, the Eagle has scored an impressive number of air-to-air kills, perhaps approaching 100, with no air-to-air losses. Its cockpit is one of the roomiest, with the most visibility of any fighter in existence, saving the F-16. The McDonnell Douglas F-15 Eagle had its origin back in the mid-1960s when the U.S. aircraft industry was invited to study U.S. Air Force requirements for an advanced tactical fighter that would replace the F-4 Phantom as the primary fighter aircraft in service with the U.S. Air Force. Such an aircraft needed to be capable of establishing air superiority against any projected threats in the post-1975 period. Without compromising the primary air-to-air combat role, the aircraft was also to be capable of performing a secondary air-to-ground mission. In 1969, the F-15 was ordered off the drawing board and production was underway. There was no prototype as such and no competitive fly-off against other manufacturers' aircraft. This raised quite a bit of controversy in Congress and the press. However, in response to criticism from those entities concerning cost overruns and lengthy delays that had occurred in previous aircraft development programs, the U.S. Air Force introduced a set of demonstration milestones which the contractor had to meet before the next stage of funding could be issued. The F-15 airframe contains 25.8% titanium by weight, most of it concentrated around the engines and in the inboard sections of the wings. The three main wing spars and the bulkheads connecting them and the frames of the engine pods are of titanium also, as is the fuselage skin forward of the main wing spar. The cantilevered booms outboard of each engine, which carry the twin fins and horizontal stabilators, are also of titanium. The first F-15s were to be powered by two afterburning Pratt & Whitney F-100 PW220 turbofan engines, pumping out a combined thrust of almost 24,000 pounds. There is a titanium firewall between the two engines to prevent a fire in one engine from spreading to the other. The ship's massive dorsal-mounted air brake is just behind the cockpit. The first rollout of the new plane occurred in July of 1972 and drew a tremendous crowd for its christening. It was the first in a new generation of superfighters that would counter anything the Soviets could put in the sky for any foreseeable future. And it was going to put McDonnell Douglas in the black for years to come with domestic and foreign sales. In appearance, the ship had a definite futuristic quality that made pilots anxious to get into its cockpit. The question now was, what was it going to carry in the way of armaments? Designed as an air superiority machine, it was also going to play a ground strike role as well. One of the first truly multi-mission warbirds for the U.S. arsenal. Movable air ducts allowed for precise adjustment of airflow reaching the turbines, which resulted in greater fuel economy and throttle control of the engine. Its dorsal air brake could provide sudden slowing of the ship in combat without having to put the gear down. This would make for an overshoot by an adversary lining up on the Eagle's 6 and cause the hunter to become the hunted. Sparrow and Sidewinder air-to-air missiles were included in the F-15's armament, as well as a 20-millimeter Vulcan cannon. The F-15 is a large, 60-foot-long, twin-engine aircraft with high, shoulder-mounted, fixed geometry-swept wings and twin tails. It is somewhat lighter in weight than the F-4E Phantom, and since it is much more powerful, it has a much more spectacular climb performance. It can get from the runway to 50,000 feet in 1 minute flat. Only the smaller FA-18 Hornet turns faster, and much of its design was borrowed from the Eagle. Both airplanes are products of McDonnell Douglas. Production of an initial batch of 30 F-15AB fighters was announced on March 1973. Deliveries to the first combat-ready wing at Langley Air Force Base in Virginia began in January of '76. The F-15s replaced the F-4Es that had previously been flown by this wing. But the introduction of the F-15 into U.S. Air Force service was not without its problems. The pilots at Luke Air Force Base with Tactical Training Wing found that they could not mount the planned number of sorties. There were a number of difficulties with parts and maintenance. But the most serious flaw was with the engines. The Air Force had underestimated the number of power cycles per sortie and had not realized how much the Eagle's maneuvering capabilities would result in frequent abrupt changes in throttle setting. This in turn led to stagnation stalling. The nature of these glitches caused unexpectedly high wear on key engine components, resulting in frequent failures of them, especially the first stage turbine blades. There were frequent groundings and delays in engine deliveries while an attempt was made to fix these problems. Strikes at two major subcontractors further delayed delivery. Once all these early snafus were cleared up, and the awesomeness of this airplane could finally be viewed in an unbiased light, it was realized that somebody, somewhere, had certainly done something right. And that fact quickly became evident to all involved with the new Eagle. Early problems with the reliability of the F-100 engines were largely overcome by modifications plus improvements in materials, maintenance, and operating procedures. The installation of a quartz window in the side of the afterburner assembly to enable a flame sensor to monitor the pilot flame of the augmenter helped to cure the problem with hard afterburner starts. Modifications to the fuel control system helped to lower the frequency of stagnation stalls. In 1976, the F-15 fleet had suffered 11 to 12 stagnation stalls per 1,000 flying hours. By the end of 1981, this rate was down to 1.5. However, the F-100, even today, still has a reputation of being a temperamental engine under certain conditions. In the late 1970s, McDonnell Douglas and Hughes Aircraft collaborated in a privately funded study of the feasibility of adapting the basic F-15 Eagle to the air-to-ground role. Back in the late 60s, the F-15 had originally been conceived of as a multi-role aircraft, but the fighter role had become paramount, and in 1975, the air-to-ground role had been set aside. In the late 80s, the F-15E Strike Eagle ground attack version of the F-15 began to reach Air Force squadrons. The F-15E is externally and dimensionally similar to the two-seat F-15D. However, the F-15E is internally redesigned with a stronger structure so that it can safely operate at takeoff weights as great as 81,000 pounds. The back seat was configured for a weapons system officer who would operate the weapons delivery systems. The aircraft was equipped with 6 stub pylons for the carriage of bombs. The Strike Eagle prototype was later equipped with a centerline gun pod and was provided with a pave-tack laser designator pod. This made the aircraft capable of delivering smart, laser-guided bombs without the assistance of a separate designator aircraft. The heart of the F-15E's electronic suite is the radar. It is intended to be used without being detected by an enemy's air defenses. The radar supposedly can be quickly switched on to obtain a single-sweep synthetic aperture radar image of a target area located as much as 45 degrees to either side of the aircraft's flight path, then rapidly switched off seconds later, making it difficult for an enemy to pick up the emissions and track the F-15E's location and flight path. Another key element of the F-15E's weapons delivery system is the LANTIRN, which is an acronym standing for Low Altitude Navigation and Targeting, infrared for night. The system consists of 2 pods, one carried underneath each air intake. The F-15E retains the 20mm cannon of the F-15D, although the ammunition capacity has been reduced to 512 rounds. However, the F-15E retains the full air-to-air capability of the F-15D version and can carry AIM-7 Sparrow medium-range missiles on the conformal fuel tank stubs and AIM-9 Sidewinder short-range missiles on the underwing pylons. The low-altitude ride in the F-15E can be quite a bit rougher than that in the F-111 because of the lower wing loading and higher gust response. The F-15E is better in diving attacks and low-level high-speed dash than it is in sustained low-level high-speed flight. The overall importance of the aircraft was evidenced by presidential interest in its performance. One of the things impressing the president most was the accuracy and precision of the Eagle's delivery of weapons in all weather conditions. On August 1st, 1990, Iraq invaded its southern neighbor, Kuwait. Saudi Arabia shared a border with both countries and saw Iraq's dictator Saddam Hussein as a loose cannon that would soon be rolling through their country. Coalition forces, consisting mostly of U.S. units with a smattering of others in the NATO alliance, and including a number of Arab countries, mounted Operation Desert Shield to stop Iraq from more military adventures and to buy time for a build-up to Operation Desert Storm, the final ousting of Saddam Hussein's forces from Kuwait. F-15s would play an important part in the 3,000-plane coalition air force that would be tasked with the mission. The aircraft the F-15 was designed to replace, the F-4 Phantom, still had a role to play in the coming Gulf War. Changes to the F-15E over the D model reflect not only the change in role, but also advances in technology. Features include the new APG-70 radar with synthetic aperture ground mapping and a wide-angle HUD, or heads-up display. From the control towers to the aircraft, desert conditions provided unique challenges to those who came from friendlier climes. Blowing sand and grit got into everything and forced maintenance nightmares on everyone. Despite the obvious heat of the desert, it can often become near freezing at night. Huge tracking radars kept track not only of coalition planes, but were on the lookout for Iraqi aircraft as well. The new 229 model of the Pratt & Whitney turbofan engines produced an additional 6,000 pounds of thrust over the older 220 model and could drive the Eagle skyward like a rocket. For the most part, Desert Shield was fairly uneventful, and no Iraqi planes came up in serious challenge to coalition aircraft. The coalition planes performing caps over the F-15's pilot cockpit is mounted high on the forward fuselage central pod behind a one-piece windshield. The canopy itself is a single transparency with only one transverse frame. It is hinged at the rear and opens up in a clamshell-type fashion. The cockpit canopy offers excellent all-around visibility. Saudis and U.S. F-15s flying in the Gulf War accounted for 32 enemy kills without a single loss. Israel also has a number of F-15s, but was specifically invited not to take part in the struggle. Had the Jewish state done so, the coalition containing Arab forces would have fallen apart, with a distinct possibility of some going over to the Iraqi side. It was for this very reason that Saddam Hussein did everything in his power to ensure that would happen by targeting Israeli cities with Scuds. The United States rushed Patriot missile batteries to Israel to counter them, and used their contingent of F-15s for several days on the great Scud hunt that delayed the start of the offensive. The 1st Tactical Fighter Wing, based at Langley Air Force Base, was the first to begin deployment of its F-15Cs and Ds to Bahrain in Saudi Arabia. The order for them to move came suddenly, and there was almost no time to prepare. But some last-minute maintenance procedures were able to be performed on the ships being deployed. On August 12th, F-15Es based at Seymour Johnson Air Force Base left for the Gulf. The F-15E Strike Eagle was still not completely ready for combat, since it did not yet have the targeting pod of its lantern system installed. The F-15Cs and Ds began to fly combat air patrols, or CAPs, in cooperation with Saudi F-15Cs and British and Saudi Tornadoes, whereas the F-15Es began to train for the strike mission, should that become necessary. During such a training mission, an F-15E crashed onto Pilots at both stateside air bases had just enough time for a cursory check of their airplanes before they were supposed to be airborne and on their way. Even at Mach 2 and above, it was going to be a long flight. All of them knew they were about to go in harm's way, but none of them cared much about that. They had the certain knowledge that they were the best in the world at what they did, and that they had the best of all aircraft to do it with. Operation Desert Storm began on the morning of January 17, 1991. Most of the air-to-air engagements during the war were fought by the F-15C, and 36 enemy aircraft were destroyed by U.S. Air Force F-15Cs during the Gulf War, against 0 losses. Many of the kills were against Iraqi aircraft caught by chance or attempting to flee to Iran. There was relatively little of the dogfighting in which the F-15 had been built to excel. Most of the kills were made by the AIM-7 Sparrow missile, which had performed so poorly in Vietnam. but which turned in an outstanding performance in the Gulf War. 9 kills were made by the F-15C with the AIM-9 Sidewinder missile, and 1 kill was credited to an F-15C pilot who maneuvered his MiG-29 opponent into flying his aircraft right into the ground. The F-15C's 20mm cannon was never fired in anger during Desert Storm. In addition, the AIM-120 AMRAAM missile was not fired in anger during the war, although there were more than 1,000 captive carries of the missile during combat missions in the last few days of the war. Although the F-15E Strike Eagle was still not fully combat ready, 48 F-15Es flew in the Gulf War. F-15Es joined other coalition aircraft in searching for and attacking Iraqi Scud missile launchers. These Scud hunt missions were largely unsuccessful, but the F-15Es attacked many other Iraqi targets of opportunity. It had much of a chance to demonstrate its low-level capabilities. Although only some of the F-15Es were equipped with their Lantern targeting pods by the end of the Gulf War, pilots claimed that 80% of the laser-guided bombs dropped by F-15Es hit their targets. However, difficulties were still being encountered in fully integrating the Lantern system with the F-15E. The commitment of the targeting pod to battle seems to have been premature, and the system was not employed in combat to its full capacities. No F-15C-D Eagles were lost in combat, although 2 F-15E Strike Eagles were shot down by ground fire. In addition, a 2-seat F-15E scored a kill by dropping a laser-guided bomb on an airborne Iraqi helicopter on February 14th. After the war was officially over, F-15Cs continued to carry out combat air patrols, enforcing the no-fly restrictions on Iraqi fixed-wing aircraft imposed under the terms of the ceasefire. Even before the advent of the Strategic Defense Initiative, an anti-satellite, ASAT, mission evolved for the F-15 Eagle. The goal of ASAT weapons is the neutralization of enemy military satellites in the event of war. The first and only launch against an actual target satellite took place on September 13, 1985, when an F-15A took off from Vandenberg Air Force Base and zoom climbed up to 80,000 feet, and then launched the ASAT against the Solwind research satellite. Both the first and second stages fired successfully, and the miniature kinetic kill vehicle separated and homed in on the satellite, destroying it upon impact. However, Congress was unwilling to permit any further testing of the system, and the ASAT program was officially terminated in 1988. In any case, congressional vision was prophetic, for barely 3 years later, the Soviet Union collapsed like a house of cards. Today, the Russian early warning defense system is in shambles, with only 3 of their 9 satellites working. Russia has no money to put up more than the F-111B, which carried aloft 26,000 pounds of bombs. The F-15 remains an integral part of the United States Air Force. Ultimately, it will be replaced by one of the new superplanes currently in development, such as the F-22. For the moment, though, and well into the new century, the Eagle, like its namesake, will continue to soar above America, keeping a careful eye out for prey. General Dynamics F-16 Fighting Falcon is one of the world's most popular fighter aircraft. It has earned its wings both in the Cold War and more recent hot ones. It has been in combat during Desert Storm and in the skies over Bosnia. The General Dynamics F-16 Fighting Falcon is one of the most significant fighters of the latter part of the 20th century. It was originally developed from a concept for an experimental lightweight fighter and has evolved into an all-weather fighter and precision attack aircraft. The F-16 has been manufactured on as many as 5 separate production lines, making it the largest fighter program in the Western world. Over 4,000 F-16s have been built, with production still continuing. As early as 1965, the Air Force had begun concept formulation studies of new high-performance fighters. These included the FX, a heavy interceptor air superiority fighter, and the lightweight advanced day fighter, ADF. The appearance of the Mach 2.8 capable MiG-25 Foxbat in 1967 frightened Defense Department analysts and prompted a redirection of Air Force fighter development, with high performance once again becoming the primary concern. The FX concept was eventually to emerge as the McDonnell Douglas F-15 Eagle, a twin-engine fighter with advanced avionics and long-range missiles. Ultimately, the General Dynamics Company would develop and build fighter aircraft. The pilot sits underneath a clamshell-type canopy whose forward and center sections are made of a single piece of polycarbonate. The ship's control system is fly-by-wire, with computers making constant adjustments in the ship's trim, leaving the pilot free to concentrate on flying and maneuvering in a dogfight, like this pilot is engaged in. The ship has no windshield arch and thus affords the pilot an unrestricted view in all directions. It makes a successful lock-on for his missiles much easier. The heads-up display, or HUD, is designed to allow the pilot to keep his opponent in view at all times while checking out his instrumentation. When he has a positive lock, he will hear a loud beeping in his helmet headphones and a light will flash on the HUD. Visibility from the cockpit covers a full 360 degrees in the horizontal and from 15 degrees down over the nose. In March of 1982, it was announced that the Air Force's Thunderbirds flight demonstration team would trade in. Transition to the F-16 was completed in November of 1982, with the first public demonstration being flown in April of 1983. In March of 1985, the team re-equipped with Block 15 F-16As, plus one F-16B, which is used for media orientation flights. The space normally used for the gun on the F-16 is taken up by an oil tank, which is used to make smoke during air show demonstrations. Fast crossover brakes are always a crowd favorite at air shows. The Air Force's Thunderbirds are a big asset in its recruitment efforts. Who can resist thinking about being in the cockpit of one of these frontline fighters while watching a Thunderbird demonstration? Only the very best of the best pilots are chosen for this duty. A tightly performed 5-point hesitation roll is an exercise in precision, an appreciation of which is even more apparent in a group formation roll. The wingtip to wingtip separation here is no more than a few feet at all times. This takes immense concentration on the part of the pilots involved. It is said that they expend a full day's mental energy in the space of 1 hour during the show. The precision continues even on the ground. The planes are all parked in a line with little or no variation from a straight line. Are also the best trained the Air Force can field. All are drawn from crack units. All the pilots and their maintenance crews have a strong attachment to their individual planes. The crews feel especially proprietary. The planes are theirs, and they just occasionally lend them to the pilots. It's a fiction the pilots are happy to go along with, because no one appreciates the maintenance crew more than the pilot it serves. It carried out over Bosnia in 1993, while rarely involved in combat, was not without its dangers. One U.S. pilot was down by a SAM and had to hide out for almost a week before being rescued. The F-16 involved flew out of Aviano Air Base in Italy. Maintenance procedures for combat aircraft are even more important, and nothing is overlooked before a CAP, or Combat Air Patrol, including extensive briefings conducted by the squadron commander. He will elaborate on the mission parameters and changes that have come down the pike in terms of rules of engagement. He will also alert the pilots to the results of the latest recon mission that will point out any new SAM sites or gun emplacements the Serbs might have put in place since the last CAP flight. Out on the flight line, an F-16 pilot will also do an extensive walk-around of his airplane. Not because he doesn't trust his maintenance or ordnance people, but simply because he is the one who is ultimately responsible for the mission and has the most to lose if it goes awry. He also gives his outboard Sidewinder missile and its connections a glance. This is his primary air-to-air short-range missile, but he won't use it unless confronted by another fighter in the skies over Bosnia. On February 18, 1994, two Air Force F-16Cs shot down 4 Serbian Galeb fighters over Bosnia-Herzegovina. This was the first offensive action ever performed by NATO warplanes. 12,240 pounds of thrust dry, 14,670 pounds of thrust full military, and 23,830 pounds of thrust with afterburners. Its maximum speed is Mach 2.05 at 40,000 feet. The F-16 armament includes a 20mm cannon with 515 rounds. An AIM 9L Sidewinder air-to-air missile can be carried at each wingtip. There are 3 hardpoints for external stores underneath each wing, plus a centerline point. In the long-range intercept role, the aircraft can carry an AIM-7 Sparrow or AIM-120A AMRAAM on each outboard underwing station. A 300 U.S. gallon drop tank can be carried on the centerline station, and a slightly larger one can be carried on each inboard underwing pylon. Type of weather. The ship is just about the lightest in the U.S. arsenal in terms of weight. With afterburners on, the ship's engine puts out awesome power. G-force buildup on many maneuvers is almost more than the human pilot can stand. It's the main reason he sits at a 30-degree incline in his cockpit. It was found that this angle offers the best practical means of distributing G-forces over the pilot's body and will help him stay conscious and in control during high-speed maneuvers. During twin vertical tails, directional stability, but that certain strake shapes actually reduce stability at high angles of attack when twin tails were used. It was concluded that a twin tail format would result in significantly greater development risks, and that a single vertical tail would give satisfactory results provided that it was sufficiently tall. Four different wing plan forms. The geometry wing was rejected because of its high area and low wave drag, but was ultimately rejected because of its high drag at lift and trim drag penalties. A low sweep straight wing was finally chosen because it was thought to offer the best combination of good maneuverability, high acceleration, and maximum lift to ensure good altitude performance by the new fighter. In February of 1975, a NATO consortium was offered the F-16 at a unit flyaway cost of $5.16 million for countries. On June 7, Belgium, Netherlands, Denmark, and Norway announced that they had agreed to acquire the F-16 as a replacement for the F-104G. A total of 348 were in the initial production contract. In its new form, the F-16 offered more new technology, superior performance, and a more attractive offset production package than any of its competitors. Initially, there was some criticism of the F-16's lack of BVR, beyond visual range, and an all-weather capability, as well as some concern about the performance problems that the F-100 engine was encountering at the time. All of these initial shortcomings have been corrected. A network of manufacturers were contracted to build the F-16 under license in Europe, while production is also ongoing at the parent General Dynamics plant in Fort Worth, Texas. The manufacture of the first production F-16 began at General Dynamics Fort Worth plant in August of 1975. The Air Force accepted its first F-16 on August 17, 1978. The first operational unit to get the Air Force Base in Utah, which received its beginning. Some thought had been given to naming the F-16 Mustang II, even though the original Mustang was a North American aviation product. The name Condor was also considered. On July 21, 1980, the Air Force announced that the official name of the F-16 would be Fighting Falcon, which was the mascot of the Air Force Academy. The prefix was considered necessary in order to avoid litigation by Dassault Aviation, which marketed an executive jet with the name Falcon, as well